Chemical properties of plastics versus short and long-term environmental effects. Polymers. A polymer is a substance which has a molecular structure built up mostly or completely from a large number of singular units or monomers bonded together. Polymers are basically a chain of monomers. Monomers are carbon atoms with 4 available bonds that can be attached to 4 different atomic groups, e.g. an alcohol. However, when monomers are attached to other monomers within a polymer chain, at most there will be only 3 available bonds. Sometimes monomers can be double and even triple bonded to each other in polymer chains, making them extra strong. Here's an example of an alcohol down here. Different types. There are many different types of polymers, including the ones we will be discussing in this presentation. There are 2 main classes of polymers, organic and synthetic. Organic polymers are substances like silk, wool, DNA, and proteins. Synthetic or man-made polymers are things like nylon, polyethylene, polyester, and Teflon. Polymers can be engineered to fit a certain purpose just by changing the polymer chain. Changing the density of the polymer can affect the look and feel, as well as the boiling point. Polymers with higher densities are harder and generally less transparent, as well as having higher boiling points due to the fact there is more energy required to break down the bonds of the higher density polymers. Examples of these are milk bottles, most water bottles, and containers for household cleaning products. So what makes a polymer degrade? Polymer degradation is a change within the properties of the polymer. Fading strength, color, and shape are early indications of a degrading polymer. The degradation of a polymer is caused by certain environmental factors such as heat, light, or chemicals such as acids, alkalis, and some salts breaking down the bonds between carbons within the polymer chain, turning the polymer chain into a bunch of lonely monomers, therefore breaking down the polymers into different types of microbial mass as shown in the diagram below.
What makes the polymers not degrade? The reason some polymers don't degrade is down to their molecular makeup. Polymers can be designed by humans and designed to not degrade. Polymers with double and triple bonds tend to not degrade. The stronger the bonds of the polymer, the more energy is required to break them down, so the harder it is to degrade. Polyethylene is an example of a double bonded polymer that does not degrade. Non-biodegradable polymers. Properties of addition polymers. Addition polymers are non-biodegradable polyalkenes. The molecules are saturated as all of the bonds holding the carbon chain together are single. This makes them unreactive and chemically inactive. This has advantages and disadvantages. The advantages are that they are very durable and safe, but being durable also means they do not biodegrade when they are in the environment, which makes them a pollution hazard. They are hard to dispose of and need to be burned in a specific way to create extremely toxic combustion byproducts like dioxins. Biodegradable polymers. Properties of a condensation polymer. Condensation polymers all contain either the amide or ester links. These links make the polymers reactive towards both acids and bases, which cause the polymer structure to break down. This is called hydrolysis. This means that the condensation polymers are very biodegradable and are not as big of a polymer as a pollution hazard as an addition polymer. How to dispose of non-biodegradable polymers. Non-biodegradable polymers are disposed of in 3 different ways. These are landfill, incineration, and recycling. Landfill is when polymers are buried in places that are dedicated for waste. This is not a very good idea because there is limited space on the earth and these spaces fill up very quickly. Incineration releases a lot of heat energy. This can be used to create electricity, but there are a lot of problems with this. The main one is that carbon dioxide is processed. This then adds to global warming, as well as the other toxic gases are also produced. Recycling polymers is a great idea, but it's not always practical. Most polymers are mixed with other materials and separating these things is very difficult and expensive.
Short-term polymers. What makes a short-term polymer? A short-term polymer is a polymer that takes a short amount of time to biodegrade. They can take less time to biodegrade because they have shorter chains and weaker molecular links. The effects of polymers degrading on the environment. When plastics break down, they become microplastics. Microplastics affect the environment for many reasons. For example, as polymers degrade and become brittle, they leach out monomers such as BPA, which can be absorbed by marine life with little known consequences. Microplastics can also be consumed by fish and other animals, and therefore placing plastic in our food chain. Burning the polymers leads to environmental pollution due to the increase of poisonous chemicals in the atmosphere. Pitcairn Island. One of the most recent news stories about a long-term polymer is one involving Pitcairn Island. Pitcairn Island is an island in the middle of the Pacific. There's a population of only 50 people, the majority of them being scientists due. It has been recently uncovered that every day 3,500 pieces of plastic trash wash up on the shores of the island, and that number is increasing daily. These pieces of plastic are addition polymers. As you walk down the beach, you can see thousands of polymers that range from objects like shoes to toys and boat buoys. This is heavily connected to our question because it shows the pollution and destruction that addition polymers can cause to our outland and waters.